A unit vector is any vector that has the size of 1.
Folks, welcome to
Vector Calculus.
Alright folks, today we're going to be having some practice. Let's practice using some different kinds of vector notation. Let's go ahead and check out our problem on the board. Alright, so here's the problem we have. Let u be a vector and it has an initial point of 2, minus 5 and a terminal point of minus 1, 3. Write the below as a linear combination of I hat and j hat. A u and b, whatever that is. W equals 2u minus 3v. If you can't read my w, I don't blame you. I can't either. Now, as you know, our motto here is that memorization is a crime. At Barry Science Lab, we believe the best way to start any linear algebra or vector calculus problem is with a picture. So let's go ahead and draw a picture. As you know, we're going to work in the coordinate plane, and we're going to start with the vector we know. What's the vector we know? Whoops, I didn't give you vector v, did I? So let me go ahead and give you vector v. Vector v is going to be 2i hat minus 1j hat. So let me write vector v in orange. So here's my vector v, there's my vector u, 2u minus 2i hat minus j hat, is that right? 2i hat minus j hat. Alright, so I've got my vectors. Let's go ahead and put them, put their picture right here. So where's 2i minus j hat? What does that mean? So 2i minus j hat means that we're going to go 2 units in the x direction and minus 1 unit in the y direction, right? And what's that going to give me? That's going to give me my first vector. Let's call it v. That's my first vector, v. And where is it going to land? It's going to land at 2 minus 1, 2 minus 1. So you already see two different ways of showing writing my vector. 2i hat minus j hat and 2 comma minus 1. When I say I hat, what do I really mean? I hat right here is simply the unit vector in the x direction, right? It has a magnitude, a size of 1, but its direction is in the x direction. What do I mean by j hat? Let me use blue here. What do I mean by j hat? Well, j hat is the same, but it's the unit vector in the y direction, right? So both of these have a size of 1, but one is in the x, one is in the y. So what this really is telling me is I need 2 steps in the x direction and I need 1 step in the minus y direction to make my vector v. And hopefully you can see that very clearly right there. Okay, and my second vector, u, it has an initial point at, let's use green for this one, initial point at 2 minus 5, so that's somewhere here, and minus 1 comma 3. So this is my initial point and my final point is minus 1 3. Minus 1 3. Wow, that's gonna be a toughie to draw, but I think I can draw it. So here's where my vector ends, here's where it starts, and we're just gonna kind of draw it. Let's see if I can get this right. Okay. Wow, that is proof that I am good. Okay, so what I did was I had my initial point, terminal point, I connected my vector, and this is going to be my vector u. Okay, so far so good. Now, that's all good, but how can I write my vector u in this way? How much does my vector u go in the x and y direction? Well, for that I need my points. What's my initial point? It's 2 comma minus 5. What's my terminal? All right, so let's see what I've got right here. So as you can see, here's what I've got. My initial point 2 comma negative 5 and my terminal point negative 1, 3. Now that tells me that my vector had to travel 3 units in the x direction, in the I hat direction. Okay, so 3 units this way. And how do I know that? Well, check it out. Let's highlight some stuff here. Okay, I'm taking negative 1, positive 2. So 2 minus negative 1 gives me 3, right? If you subtract these x coordinates of the initial and terminal point, you'll find that I have to travel 3 units in the x direction to get over here. Now, I have to still travel 8 units up the same way. Okay, if you do 3 minus negative 5, you'll find that we have to travel 8 units up. So 8 units, 8 times the j hat vector, the unit vector in the y direction. Okay, and that tells me since I have to travel 3 units this way and 8 units up to get my vector u, the coordinates of vector u, or rather the components, will be 3, 8. And so u will be 3, 8. Another way you can write that, since it says a linear combination of I and j hat, is 3 of I hat and 8 of j hat. Because really we're taking 3 steps in the x direction, 3 steps of I hat, and 8 steps in the y direction, 8 steps of j hat, right? Okay, what about this question? 2w is 2u minus 3v. How do we write that as a linear combination? Think about it. Think about it before you watch my solution. Well, all I have to do is take 2 of my vector u. What's my vector u? It's 3, 8. It's 3, 8. And what's my vector v? Well, I'm going to take 3 of whatever my vector v is. My vector v is 2 minus 1. 2 minus 1. And so I find that 2 of this vector is going to be 2 times 3, which is 6, and 2 times 8, which is 16, minus 3 times 2, which is 6, and 3 times negative 1, which is negative 3. And now you just subtract them, right? What's 6 minus 6? Well, 6 minus 6, we hopefully all know is 0, and 16 minus negative 3 is positive 19. And that, ladies and gentlemen, is it for this lecture of vector calculus, and that's how you use linear combinations. We'll check you out next time.